try to cover reciprocals. It's a long subject, takes a lot of practice, and ultimately it comes down to knowing your parent function. And if I had to say one thing about these courses, the one thing students avoid is studying the parent functions, and it's the one thing that'll save your butt. And they just don't study them enough. Now, on all your functions, you should know at least 3 points. But this one, or 4 points, but this one's a really odd one. And it's really odd because it doesn't follow the similar patterns. Now, the transformations will still follow the same patterns. If I add 3 here, that's a y transformation upwards by 3. If I put a multiplier in front of the whole thing, that's a y stretch by a factor of 3. If I subtract 2 from x, it's all going to move to the right by 2. It's transformation to the right. So the transformations work the same. But what's hard for people to understand is why this thing looks the way it is, and it would really be no different than a flat line like this if it were for not one thing. The rules of math. And the rules of math state quite clearly that you cannot have a 0 at the bottom. The other big rule of math is you can't square root of negative. So as soon as you have an x at the bottom here, it's very clear that x cannot be equal to 0. X cannot be equal to 0. That means this whole graph, as we're traveling along it, is coming closer and closer to x is equal to 0, but can't quite get there, but keeps trying to come as close as it can no matter what. Now, here's another important thing I'm doing. You should be able to memorize what y does when we get close to this, and that this is the parent graph. Y starts diving straight downwards to negative infinity. You should also understand what y does as x gets really large, negative infinity over here. Y tries to hug 0, never reaches it. What does y try to do on the other side of the asymptote as it gets close to x is equal to 0? It tries to reach positive infinity. What does y do as x gets huge in value, x positive infinity? Well, y approaches 0 again. Knowing this basic behavior will help you understand how to graph all of them, because they all do this. They all tend to hug their horizontal asymptote way out here. They all tend to hug their vertical asymptote up close to the vertical asymptote. Same here, no matter what happens. But notice that x cannot be 0. As a result, we have a vertical asymptote at x is equal to 0. But also as a result, there's no value I can put into this x that will create a y of 0. I put in 0.0001 for x here. I'm going to get 1 divided by 0.0001. I'm going to get 1 y is a million, which means if I get x down to 0.001 on the positive side, the y value is going to be way up here in a million. We can see this when I put it into f of x, and I can throw in some values. F of 0.00001. Look at that. What about another few more zeros? Oh, y keeps climbing. So we can get close to x is equal to 0, but never get it. And in either case, if I approach x to 0 on the negative side, 0.0001, y approaches negative infinity, negative a million right there. So it really helps to understand these graphs and play around with them before you get to the next step, which is graphing something more complicated. Right away when I graph this, I can say, well, x can't be 0, so I know there's an asymptote here. And as a result, y is never going to be 0. And this is the easiest way to remember this is when the x power up top is less than the x power down below, y is equal to 0 will be the asymptote. So these are the two asymptotes right away. Now I want you to notice something. If I add 2 to the x down here, I'm shifting the whole thing to the left. As a result, my asymptote has also shifted to the left. That's something that you should connect. Okay, so whatever the asymptote is at the bottom, see, I can't have a negative 2 as x down here, so that's my new asymptote. And you can just set the bottom to equal to 0 to figure it out. Now, obviously, it's going to get more complicated, but I wanted to show you that if I just set this to, if I have just add a random number to this and call it a, and add a slider a, and I make my asymptote also equal to a, watch what happens when I move the a around. Oh, I've got to make my asymptote negative a, because it's the opposite. Well, look at that. The asymptote and the graph are sliding left as right as I add or subtract an a at the bottom of x. All this is doing is translating, but it's also translating the asymptote. But notice the horizontal asymptote, still at y is equal to 0, because no matter what value I put into x, I get close to 0 on the y, but never get there. So that's an interesting thing. I also want you to note that no matter what I put up here, I'm going to hang off on that. I'm going to go back to the basic, 1 over x. Well, how does the horizontal asymptote change? Well, the horizontal asymptote will change, and I'll get to that in a second. But your first number one step is always try to figure out the vertical asymptote. If it says x minus 2 down here, what would x have to be to make this whole bottom thing 0, which is what we're not allowed? Well, x would have to be 2. That means that when x is the asymptote is going to be at x is equal to 2. It's very easy. Whatever the bottom is equal to 0, that's where the horizontal asymptote is going to occur. Where it gets more complicated as we add more fractions. So obviously when we're in a situation like this, it can get pretty complicated. But it's clear that there's going to be two possible asymptotes down here. When this bracket is 0, it'll make the whole thing 0. And when this bracket is 0, it'll make the whole bottom thing 0. So obviously when x is minus 4 here, we're going to have a vertical asymptote. And when x is positive 2 here, we're going to have a vertical asymptote. So boom, right away I figured out my vertical asymptotes. But look at that. Why is my horizontal asymptote now no longer 0? It appears to be y is equal to 1. And it's true. That is now the new horizontal asymptote. Well, we're going to get into horizontal asymptotes. But the number one thing you need to figure out is vertical asymptotes. And I also want you to notice something. On the left side of the graph of the asymptote, of the green asymptote here, the graph is going up and to the left. But to the right of it, it's doing an opposite behavior. So while it was climbing up here, it's doing the opposite down here. Now, that's not always the case, but it's good to know that both are hugging the asymptote. The question is, will it be hugging the asymptote down here, or will it be hugging the asymptote up here? And the rule is, it will be hugging the asymptote somewhere. But this one does a weird one, right? It crosses that horizontal asymptote and goes into this situation. That's because it crosses the x-axis at 2 points, here and here. Let's see if we can see a relationship in the graph of why those cross the x-axis at those 2 points. And sure enough, it's related to the numerator equaling 0. That's where you'll cross the x-axis, so long as it doesn't conflict with the bottom. Whatever that is set to 0 will tell you where it crosses the x-axis. I also want you to notice that to the left of those points where it crosses the x-axis, the graph is on the negative side on this one. And then when it crosses this x-axis, it is crossed over to the positive side. It must always do that, and if it had a chance to come back before it reaches this asymptote, it would cross down into the negative. But of course, we know it can't cross over here. These are the only two possible x-intercepts. We'll get into that more. But the big question is, why is the horizontal asymptote the same? Well, I want you to look at what happens. The other thing is they're going to give you the graph like this. So your number one tool is going to be factoring. Your number one tool is going to be factoring, because they're always going to give you a graph like this. Now, almost always the bottom will be factorable because they want you to figure out the vertical asymptotes. Sometimes the top is not, but you can still use the quadratic function to figure out where it crosses the x-axis if it does at all. So get back into your quadratic function formula. Down here, this graph is the same as that up there. It's the exact same. I'll turn both these graphs off so that you can see. Purple on, red off. See, they're the exact same graph. This is just the expanded version. They're always going to give you this, and you're going to have to factor to that. But I want you to notice that I have a power to the x squared up here and a power to the x squared there. And you can always figure out the x powers by just counting up how many multipliers there are. There's 1, 2 x's here. They're going to be multiplying. There's 1, 2 x's here. They're going to be multiplying. Be careful, because sometimes you'll see a squared up here, and that will mean that there's x cubed down at the bottom. You might even see an x squared in the bracket. That means that those x's multiplying out will create an x cubed. So again, you have to have a knowledge of what happens when you expand these brackets. But I wanted more to show you. This is a great example of how to map it out. So once I get this and I factored out successfully to this, I immediately, step number 1, figure out the vertical asymptotes. Well, I know this can't be 0, so I can say x is equal to minus 4. And boom, I should draw a line right on my graph, x is equal to minus 4, and know that the graph can never cross a vertical asymptote. It can cross a horizontal asymptote, but not a vertical asymptote. Where's the other vertical asymptote? Right there. Boom. So I can right away draw another asymptote, but x is equal to 2. Notice the graph does not cross that vertical asymptote. Also notice its behavior is different on either side of the asymptote, but that it hugs the asymptote. It either goes way up to y infinity and hugs the asymptote, positive infinity, or way down to y negative infinity and hugs the asymptote. But that's its two options when it's near the asymptote. Look over on this side. As it goes down here, it hugs the negative goes down to negative y infinity as it hugs the asymptote, and up here on the left side of the asymptote, it goes up to positive y. Now, what happens way to the left or way to the right of these graphs? Well, it will hug the horizontal asymptote. Now, be warned, they are allowed occasionally to cross the horizontal asymptote, but not the vertical asymptote. So how do I figure out the horizontal asymptote? Now that I figured out step one, figure out the vertical asymptotes. Horizontal asymptotes are strictly dictated by the powers. When the powers match, these powers match, you look at the numerators in front of the coefficients in front of them. I got a 1 and a 1. You simply realize that the horizontal asymptote will be the coefficient up top divided by the coefficient at the bottom. And boom, there's the horizontal asymptote. Y is equal to 1. That's your second most important step in mapping these out. How do I map out the rest? Because obviously, Peter, you're using a graph, and I'm not going to have a lovely graph. Well, you're right. I'm just going to have a factored formula like that. So if I can't get from here to here, yeah, you're pretty much not going to get there. But that's why they have you working on factoring. There are some exceptions, such as canceling out, that I'll cover in a second. But I want to work with this one, because this is a great example of figuring out the vertical asymptote right away and the horizontal asymptote right away. But how do we work from paper? Good question. Here's the rule. You've got this. First step. Figure out the vertical asymptotes. Easy. I just got to focus on the numerator, on the denominator. First, figure out your vertical asymptotes. X is equal to 2, definitely. At the bottom, x is equal to minus 4. Great. Second step. Figure out your horizontal asymptotes. Easy. These both expand to x squareds, and I can see that there's a 1 in front of this one, and a 1 in front of this x, and there's a 1 in front of this x, and the 1 in front of this x. So the most they're going to expand to is x squared up top and x squared at the bottom. If I take 1 as the coefficient in front of this x squared and 1 in front of this x squared and divide it, I get y is equal to 1. So that is going to be my horizontal asymptote. Great. Next, third step. Oh, let's get rid of that. Third step. What are the x-intercepts? And that's when y is equal to 0. Well, the good news is you don't have to worry about the bottom of this. You just have to look at the numerator. So when will the numerator be equal to 0? Because for y to be 0, it's really the numerator has to be 0. The denominator can't be 0. That would be a foul. So we have to look at when will the numerator be equal to 0. Well, that's when either of these brackets will be 0. And when is this true? Well, when x is equal to minus 3. And when x is equal to 6. So that means I'm going to have two intercepts, minus 3 comma 0 and 6 comma 0. Great, a lot of information already. My next step is, first of all, I'm going to draw, oh, and here's another helpful thing that you should do. Fourth step. See what the y-intercept is. The y-intercept is when x is equal to 0. So we're going to plug 0 into the top, we get 3. 0 into the top, we get minus 6. It's all going to be divided by minus 2 times positive 4. What's the top? It's minus 18. What's the denominator? It's minus 8. We don't have a clean fraction, but we get roughly 2 and a half. So, and it's negative divided by negative, so it's going to be positive. So when x is 0, y is 2.5. Let's go back to the graph and see if that's true. When does it cross right here? I might have gotten it off of it. No, 2.25. I divided my last fraction incorrectly. But 18, if you take your calculator out and you take negative 18 and you divide it by negative 8, it becomes positive and you get 2.25. So all I did was a minor division. So I get 2.25, which means I have another point, 0, 2.25. Very handy for graphing. So let's just start and make my life a little bit easier. Start with the graph. Right away, I know that I have a vertical asymptote. I'm going to color my vertical asymptotes. I know that there's one at x is equal to 2, and I'm going to label it because I'll get points. And I'm going to make another vertical asymptote, and I'm going to keep it in red, and I know that x is equal to minus 4 at my other vertical asymptote, and I'm going to label it. x is equal to minus 4. Now, in green, I'm going to label my horizontal asymptote, which I fortunately discovered that is y is equal to 1. That's a little too high, so I'm going to put it there. And I'm going to label it y is equal to 1. You can even say vertical asymptote or horizontal asymptote or whatever you want. That'll help as well. Now, I also want you to notice that it's going to do something hugging the asymptote and hugging the asymptote and something hugging the asymptote and hugging the asymptote to the other side. But no matter what, when it gets close to the asymptote, it's going to be hugging either up or negative. So that helps in knowing which way it's going to go. In the middle, it's either going to turn around at the horizontal asymptote or it's going to cut through, one or the other. And because here's the other thing, because there's only 2 vertical asymptotes, that means this graph is only going to have 3 distinct areas. Remember that. You're going to only have 3 graphs because there's only 2 vertical asymptotes. The horizontal asymptotes do not divide the graph at all. But let's put in the points we do know. We know that there's some intercepts right here. So I can even mark some dots on my graph right here. Minus 3 I know is to the right of minus 4, so I know it's going to be right about there. I'm going to just put a very rough mark. It's not quite right, and it's pretty messy. And then I also know there's another x-intercept right here, because I figured it out. Notice that 6 is to the right of x is equal to 2, so I can actually mark it right there. It's going to cross. That already gives me an idea. That pretty much tells me that this graph is going to do this, because it can't do this. It can't be hugging. It can't be going down here. It's got to hug the horizontal asymptote as it goes to the right and the vertical asymptote as it goes to the left. That's the nature of that. So right away, by studying the natures of these graphs, it'll help a lot. But these 3 spots help a lot. Now, here's the other spot that helps a lot. The y-intercept, 0 at 2.5. Now, I know this line is y is equal to 1. So I know that dot is above here at 0.25, which probably means because I have 3 sections, only, that almost automatically tells me the graph is going to look like this. And remember, this black line is not a vertical asymptote. That's the Cartesian graph itself. So boom, I know it's got to hug the vertical asymptote as it goes down. I know it goes through this point. And I know it can't do this because it doesn't come back through the x-axis again. I don't have another x-intercept. So it doesn't do this, even though it could if I had another x-intercept there. It must, because it doesn't have another x-intercept, and it must hug the vertical asymptote, go like that. But let's not do that instead. Now, I have 3 distinct areas, and it can't do this either. It can't, like, bounce back, because a bounce back would mean this is squared, and it's not squared over here. So I already know from my studies of how graphs behave from various things that it must be do that. But let's pretend I don't know that. Here's where the graphing begins. There are 3 distinct areas, and I'm not going to count 2 of them, which is negative x infinity and positive x infinity, although it will help to do that. There's to the left of this x-intercept, and there's to the right of this, there's to the left of this vertical asymptote, and to the right of the vertical asymptote right up to the x-intercept. Then there's from this x-intercept, and with this one doesn't matter, all the way what happens to the graph in between here and this vertical asymptote. And then the next area of concern is what happens between this vertical asymptote to the right of this and what happens to the right of this all the way up to positive infinity. The horizontal asymptote plays little role in my drawing except that when I'm finishing the touches. So again, here's the best thing to do. Take a long line with lots of room, like this. Make it black. And say, okay, way over here is negative x infinity. Negative x infinity. I should figure out what's going to happen there. But then you should come all the way over here and give yourself lots of room to draw. And say, okay, what's my next spot? Well, it's when I hit that x-intercept. So x is equal to 9 at minus 4. What's my next spot? An vertical asymptote or an x-intercept? It's an x-intercept when x is equal to minus 3 is the x-intercept. Okay, when's the next spot? It's an asymptote or an x-intercept. It's an asymptote at x is equal to 2. So you're just going in order. And what's the next spot? Well, it's the x-intercept at x is equal to 6. And give yourself lots and lots of room in between those to map things out. Okay, and what's the next step after x is equal 6 intercept? Well, it goes on forever. There's no other horizontal asymptotes. It's positive x infinity. Great. Now that I've mapped out the 4 areas, and it's based on vertical asymptote, x-intercept, vertical asymptote, x-intercept, and infinity, and those are the only 4 points of concern. I don't care about this dot. I don't care about the horizontal asymptote. Those are the only 4 points I'm going to map. And then you're going to take a line, and you're going to draw it straight down through those. Straight down through those. And you're only concerned about what happens on to the left and to the right of those lines. So we're only concerned what happens between these 2 black lines, and it doesn't matter which point I take between these 2 black lines, because the graph will not magically cross anything. It can't. It's not allowed. I figured out all the possible x-intercepts where it can cross. It's not allowed. It must hug. It must hug somewhere. So I need to figure out what happens in this zone. So I can even colorize that. I need to figure out what happens in this zone. And then I got to do the next zone. So I can take any x value between those 2 x's. And then I need to figure out what happens in this zone. And I'm going to colorize it. Woo, I didn't colorize it well. And then I need to figure out what happens between these 2 x values. And I might as well take the easiest x values between. Keep in mind, if you don't know what's going to happen near the asymptotes, you can also take a value of x right near the asymptotes. But from lots of graphing, you should get used to it. So I only need to know what's going to happen between these guys over here. And then finally, you're going to be able to study anything on the left and anything on the right. Now, if you still don't get a clear idea of graphing, you can then take marks right close to -4. Like just on the left side would be -4.001 and 4.001. And that's where, just on the right, to see if it's hugging way up here or way down here. And then on the other side, way up here and way down here. And by the way, if it's hugging way down here on the right side, chances are good it's going to hug way up here on the left side. That's what it tends to do. If it's heading down here, it's suddenly going to appear up there, like almost automatically. I can't really think of many exceptions. There are some, I'm sure. But generally speaking, that's what we should be thinking about. So let's look at that. Let's just take some easy values in there. Well, I might as well look at negative infinity to see what this graph does as x becomes huge but negative. And here's where you take each of these things, no matter what's up here, even if there's a -1 in front, you have to use it as a multiplier, and you're going to put them each down here. And you're going to put a plus and a minus beside them for negative infinity. Okay, so there's the numerator. So I might as well do now the bottom. And I'll do the denominator by the bottom. Now the good news is when you're dividing, multiplying, it does the same thing to the negative. So you only have to figure out if negative infinity makes any of these brackets positive or negative. So let's start with here. Obviously for this one, negative infinity is going to overwhelm +3 and it's going to make it negative. Negative infinity here is going to become negative. Negative infinity here is going to become negative. And negative infinity here is going to become negative. So that means we're going to negative times a negative divided by a negative times a negative. So if negative times a negative up top becomes positive, and negative times negative on the bottom becomes positive. So that means that the result of this will be a positive y result. And guess what? If we were to put it in a calculator, it's going to be very close to +1. But the question becomes, oh, is it on this side of -1 or this side? So we know it's really close. And we could take an exact value if we wanted to. So what's going to be, let's just take 100, okay, for x, because if it's on the north side of y, it's probably going to be on the top side of y. So let's take 100, just to see which side of the horizontal asymptote it's on, above it or below it, because that's going to tell us everything. What happens at the top? 103 times 94. What happens at the bottom? Oh, sorry, negative. So we're using negative. So it's going to be negative 100 plus 3, negative 97. Negative 100 minus 6 times negative 106. The negatives don't matter. We know it's going to be a positive number, but we'll just put it in there. Minus 100 minus 2 at the bottom, minus 102. Minus 100 plus 4, negative 96. Now let's take our calculators. Let's take our calculators. Remember that this part is the numerator. This part is the denominator up here in this equation. Oops, I opened my Excel sheet, which won't matter. Here we go. So I'm going to take negative 97 and it really doesn't matter because it's going to become positive, and negative 106. And I get this. And I'm going to divide it by, open brackets, negative 102, and I'm just going to leave it positive because it's going to become positive, times 97. I'm just going to leave it positive because it's going to become positive, and I hit equals. And I see that this is slightly above 1. And I know my horizontal asymptote is above 1. And that tells me pretty much everything. That means it's on the top side. It's on this side of this horizontal asymptote, which means to approach this vertical asymptote, I must do that. But you know what? We'll just leave it questionable for now, and I'm going to make my main line purple. But I'm almost 99% sure now it's going to do something like that. And not quite as pretty. There, like that. Almost 100% certain it must do that because it doesn't cross the horizontal that often. And by the way, to see if it crosses the horizontal, you just make this equal to 1. And you see if it can equal to 1. And I'll do that in a second. That's how you figure out if it ever crosses the horizontal. But let's just continue this way, okay? Well, I'm not 100% sure, so I'm going to just take a value of x that's just to the left of minus 4. What's just to the left of minus 4? Minus 5. And I'm going to plug it in up here. And I'm going to get minus 5 plus 3, I get 2. Minus 5 minus 6, I get minus 11. 2 minus 11. So these are the numerators. So I'm going to get minus 22 up top. And down below I get minus 5 minus 2 is minus 7. Minus 5 plus 4 is 1. So I'm going to get minus 7. So I'm going to get a minus divided by a minus. So it's quite clear that I'm going to get a positive result, which is going to be up here. And it's also quite clear that the top was minus 22 and the bottom was minus 7. And that's roughly positive 3, which means it's climbing up and it must hug the asymptote. So right away, I'm almost 100% certain that that's how I'm going to graph the left. So the only question is what happens in between this asymptote and this x value. Well, very tight, minus 4 and minus 3. I can really only take minus 3.5, right? I can really only take minus 3.5. Let's get rid of all my messy drawing here. Minus 3.5. And generally speaking, you're only going to seek out minus values most of the time. But we might as well get a good idea of what happens. I'm trying to determine, is it down here below the x-axis, or is it up here? Does it come down like this, go through, and then down? And I'm almost certain it doesn't because of the explanation I had before. I'm almost certain I'm going to get a negative number. But I want to work with a number between minus 4 and minus 3, so that's minus 3.5. So over here, minus 3.5 will become negative 0.5, negative 0.5. And minus 3.5 minus 9, minus 6 will be negative 9.5. 0.5 times negative 9.5, both of them negative. Down here, I get negative 3.5 minus 2. It's negative 5.5. And here's the only problem. I get a negative 3.5 plus 4, and that's positive 0.5. So if I get a minus times a minus up top, I'm going to get a positive. But down below, I have a minus times a positive down below, so that's going to stay negative, which means the overall result is going to be negative, which tells me I'm on this side of the graph between this 3 and that asymptote, which tells me my graph must do this. And yeah, I can figure it out more and do more work, and it's bad drawing and all that. But I'm almost certain of it. So I can just get rid of all my numbers. And sorry, I always get a little bit messy in these things. And I get rid of all my numbers and go again. And it's going to be much simpler now because the numbers between minus 3, and it doesn't really matter here because I know it doesn't come back to the x-axis. There's no more x-intercepts. It must continue up, which means it crosses one time for sure. It would help to know this dot too and through, and it must hug the other asymptote. It's not going to come back. It can't. My knowledge of drawing says there's no x-intercept. There's no way it can come back, so it can't. It must always seek to hug those vertical asymptotes. The only question now is it going to come down here or is it going to come up here? Well, look, it goes through this dot. I'm now almost certain it must hug this asymptote here, go through this dot and come up here, but let's make sure. Let's find a dot just to the right of 2, which would be 3. And 3 here makes 6. 3 here makes minus 3. 3 here makes 1. And 3 here makes 7. So that means I'm dealing with a negative number up here. I'm dealing with negative 18 up top. And down below, I'm dealing with a 1 times a 7. 7. Negative 3 divided by 7 is negative a half. So it's roughly about here, somewhere around here. So I can see that I was indeed right. It's going to do this. And it's going to do this weird thing. And I actually have to pull it down a bit. Maybe do that. And it's actually going to do something more like that. So I'd have to redraw it a bit better. Go through that point and try to draw it. Close. Not great, not bad. Close enough. And just remember that I must go through that point right there. And it's going to look like something like this. Now I can do more test values and more figuring out. But this is the method. You figure out what's happening to the left of the asymptote. You figure out what's happening between the asymptote and the next asymptote or x-intercept. What's happening between the next one and the next one and the next ones. And the only ones you're concerned about are the x-intercepts and the vertical asymptotes. Everything else is going to map out itself. Okay, but Peter, you told me it just crossed the horizontal asymptote. How would I figure out where that crosses? What is the horizontal asymptote? It's y is equal to 1. So that means the y value when it crosses must be equal to 1. So I can set this whole thing up to equal to 1. Let's do that. It would help if I use the expanded version. So I'm going to take a picture of the expanded version, which I would know because that's how my test would start up, right? It would start off with the expanded version. And I'm going to take it like that. All right. And here we go. If this is equal to 1, how do I solve it? Well, I want to get all this from the bottom to the top, which means I can multiply, since this is being divided by all of this, I can multiply both sides by this and this. It'll cancel out on the right side when I multiply both sides by it, and I'm left with this. All right. That's what I'm left with. Now, I can set the whole thing equal to 0, or to the numbers, rather. I can get all my x squareds to this side and all my numbers to that side. Okay, so I'm going to have to subtract 1x squared from both sides. And when I do that, look at that. Those x squareds will cancel out. All right. This is just good old-fashioned algebra at this point. I'm left with this. Well, I want all my numbers to the right side because clearly it's solvable, and I want all my x values to the left side. And I just want to make sure that 2x is mine. Now it's positive 2x. That's positive 2x right there. So I'm going to subtract 2x to this side, and I get minus 5x. And I'm going to add 18 to this side, and I get 26. And now I'm going to divide by, I don't think I have do I have a positive number or a negative number? Hang on. Minus 2x, make sure I got this right. It's going to be should be a positive, oh no, it's going to be a negative value of x because I'm on the negative side. So I'm at negative 5x is equal to 26. And I divide both sides by 5. And I get x is equal to 5.2. So that means the value here that I can also map out for extra points is 5.2 negative. It's a negative because it's a positive. That's not 26, sorry. Negative 18 plus 18 on each side to get rid of it here. Plus 18 on each side is a 10. So I get negative 5x is equal to 10. My bad. Dividing it, I get x is equal to negative 2. Which means it crosses right here. There's another new point, negative 2, comma 1. Let's go to our graph and see if that's true. There it is right there. Let's get rid of that one. Negative 2, comma 1. Look at that. By setting it equal to our horizontal asymptotes, we solved it. So those are the big steps. Step 1. Once you figure out your vertical asymptotes, you've figured out most of it. Second step, figure out your horizontal asymptote using the rules. Now let me go through the major rules. Here's the major rules. If x power up above is less than the x power down below, your horizontal asymptote is y is equal to 0. If they match, for instance, if I have 3x squared here, if they match, you just cancel those out and you look at their numbers. 3 divided by 1, that means my y is equal to 3 as my horizontal asymptote. Here's the last weird rule. When the power up above is more than the power below, you're going to get what's called a diagonal asymptote. And there is a way to figure it out in later grades. But that essentially means there is no rule on the horizontal asymptote. So don't use it as guidance. However, you will see this weird thing that often looks like this, where if you look way out here at the line, and the way out here at the line, it'll look like a diagonal line. And I'll show you an example. So, step 1, first figure out your vertical asymptote. Step 2, figure out your horizontal asymptotes. There's 3 possible rules. Step 3, figure out your x-intercept by factoring the numerator and setting it to 0. Step 4, see what your y-intercept is by setting your x to equal 0. Step 6, draw what you know. Step 7, do a line chart like this. So I'm going to write that down as draw what you know, and I'm going to send this to you. Draw what you know. Step 7, do a line chart like this. Figure out what the y values do in each indication. Also know your basic knowledge. It's going to hug a horizontal asymptote either way down here or way up here, a vertical asymptote, sorry. It's going to hug the horizontal asymptote. It might even cross it, but it's going to eventually hug it as it gets negative infinity and positive x infinity. That's the nature of these things. That's what you can count on. Also, please note, sometimes it will cross the horizontal asymptote. So that would be step, I don't know what we're up to, step 6. Set your equation to equal the value of your horizontal asymptote and see if you can solve for x. If you can't solve for x, if you come out with a null value like 7 is equal to 2, then you know it does not cross the horizontal asymptote. And then just verify, if you're uncertain, take a few spots just to the right of the asymptotes and see what values of y you get. Another way I want to point out is you don't always have to do the numbers thing here. You don't always have to figure out the exact values over here. You can figure out if it's positive or negative. So let's take a value between x is minus 3 and x is 2. Well, the simplest one was when x is 0. And we already figured out it's 2.5. But when x is 0 here, positive. When x is 0 here, negative. When x is 0 here, negative. When x is 0, positive. So that means the bottom is going to be negative and the top is going to be negative. And when you divide, you end up with a positive, which means my graph between this y-intercept, this x-intercept and that asymptote will be positive. That's what it means. Positive means it's above positive y values. That's what positive means. Which means it won't bounce because that would mean that this over here is squared, and it's not. So that means that this between this and this will be negative. But to verify, I can just roughly take negative 2.5 and say this is going to be positive. This is going to be negative. This is going to be negative, and this is going to be positive. Let me try that again. Negative 2.5, this is going to be positive. This is going to be negative. Oh, sorry. I'm still in the positive zone. This would be negative 3.5. Negative 3.5. This is going to be negative. This is going to be negative. This is going to be negative. And this is going to be positive, which means up numerator is going to be positive. Or if you just divide them, positive, negative stays negative. So that means on to the left between the x-intercept and the vertical asymptote, the graph is negative. Almost always it's going to flip up here, but you can always just take a value that's just to the left of negative 4 if you want, or just negative 5 and just see the positive or negative. So if this is negative 5, we get a negative. If this is negative 5, we get negative if x is negative 5. If x is negative 5, we get negative. And if x is negative 5 here, we get negative. So a negative divided by a negative divided by a negative divided by a negative is positive, which is why this part of the graph just to the left of the asymptote is positive and will always be positive because it does not cross the x-intercept anymore. The only time a graph has a chance to go from negative to positive y values is through the x-intercept. That's why we figure out the x-intercepts. Hope that helped. I know I talk fast, but it's because it's a lot of information in a short amount of time.